Hi everybody. So here's what we have learned so far. We learned how to calculate molarity, and molarity tells us about concentration, and we learned that we calculate that by doing moles divided by the liters of the solution that we have. So moles of the solute divided by the liters of the solution. And then we've got some vocabulary words that we have to make sure that we understand, that the solute is the material that dissolves and the solvent is the material that the solute dissolves into, which is usually water. So molarity is one way to know the concentration of a material. The more the molarity is, the higher the molarity, the more of the solute is dissolved in the solution. So the stronger the concentration is. So now we're going to learn another way, which is percent concentration. So you can see that we have our formula right up top here. And this is a PDF that you can grab off of Schoology for yourself, or you can just grab a piece of paper and write down these practice problems as we go through them together. So we have our equation up here that we're going to use in order to solve these problems. So we just need to find our pieces of information. So for example, the first problem tells us that we've got 25 grams of solute. So that's our top number. And we have 175 grams of solvent. So in order to calculate our percent concentration, we would take 25 grams of solute, divide it by 175 grams of solvent, and multiply it by 100 in order to get it into a percentage. So our answer to this problem would be 14.3%. Go ahead and pause the video here and see if you can do a couple of these next problems on your own, and then unpause it and continue watching to see if you did them correctly. So here's the answer to number 2. Check your work and make sure you got the same as me, 5.66%. Number 3, there's a few things that you've got to realize. You have to remember that 1 milliliter of water has a mass of 1 gram. And so then we also have to remember that 1,000 milliliters would be 1 liter. So remember, we've got 1 liter of water. So that would make the mass of that solution be 1,000 grams. Now, for the bottom number on number 3, we have to remember that that bottom number is the total mass of the solution. So if we've got 15 grams of solute going in and we've got 1 liter of water, well, then the total mass of the solution is actually going to be 1,015 grams. So you've got to be very careful on a problem like that. Which that just made me realize that we've got to go back up here to number 1. I just noticed that this problem says that we've got 25 grams of solute and 175 grams of solvent. So that actually means that our total mass of our solution is going to be 200 grams. So I'm going to leave this. I'm not going to redo the video because I think this is really good to show you how easy it is to make a mistake like that. So we're going to have to do 25 divided by 200 because that's the total mass of the solution, the solute plus the solvent. So we got to make sure that we remember that the solute plus the solvent is going to give you that total mass of solution. So that means that number 1 here is going to actually be 12.5%. Okay. This one here is fine because it tells us that it's the solution. Notice the word solution right here. So it's okay to have the 300 on the bottom there. We just have to be careful as to what pieces it's telling us. Is it actually telling us the total mass of the solution at the end, or does it do like number 1 does? So we've got to be careful with that. So going back to number 3, if I take 15 and divide it by 1,015 and then multiply by 100, I should get an answer of 1.48% for number 3. I'm not going to have you worry anything about parts per 100. I want us to just focus on this this calculation right here. So at this point, we've got two different equations that we've learned. We've learned the molarity equation here, and then we've learned this percent concentration, both of them giving us a way to express the concentration, giving us a way to express the strength of a solution. So I would maybe put these two on a little note card or a piece of paper for yourself so that you can reference it anytime we're taking a quiz and for the test for this particular unit. Okay, go ahead again and pause, see if you can figure out number 4 and 5 on your own, and then continue playing to see if you got them right. So for number 4, the first thing I did was I took our concentration, our percent concentration, set it equal to the unknown amount of solute over our grams of solution, which goes there, times 100. So then the next thing I did is I first divided by 100 in order to get rid of the 100 over here, and divide this by 100. That gets rid of the percentage. So then we have 0.005 is equal to x over 100. So now we have to solve for our x. And solving for our x, we would multiply this side by 100 so that the 100 on the bottom cancels out. Multiply this side by 100. And so our x, which is going to be giving us our grams of our solute, is going to be 0.5 grams of our solute is what we'll need for number 4. Again, pause it, try to do 5 on your own, and then come back. All right, finally for the last one, we've got 0.75 grams going into 1 liter, which would be 1,000 grams. So that would give me a percent concentration of 0.075. And then if I take a look at the other solution, I've got 1.50 grams going into 1 liter. So that would give me a 0.15% concentration. And so if I compare these two, I would have to multiply my answer in pink here times 2 in order to get this other solution. So that would mean that this is 2 times more concentrated. The second one is over the other one. So you are going to take a exit quiz, a practice quiz on these percent concentration problems. Again, just one problem as usual to check your understanding, and then continue on this video so that you can see the next assignment that you're going to be doing. So you've got an exit quiz, and then of course continue watching this video to see what the other assignment is. So the next thing that I want to talk about is diluting a solution. So whenever we have some sort of solution, again, I like to think of it kind of like if I've got some Kool-Aid made, and again, if I had a really weak concentration of Kool-Aid and I diluted it some more and I added more water into it, my volume would go up, and but my amount of Kool-Aid, which is my solute for this, would remain the same. And my concentration goes down because I'm increasing that volume by increasing the solvent. So I would have a less concentrated Kool-Aid then. Let's say that I made some Kool-Aid and it was way too strong. Well, I can simply add in some more of that solvent in order to weaken that concentration. So one of the things we can do in order to dilute a solution is to add more solvent, which is the material that it's dissolving into. So in the case of the Kool-Aid, I'm adding more water to it, or I'm increasing my volume, okay? And so what happens when I do that is I reduce the ratio. I reduce the number of moles of solute per unit volume, but I don't actually change the total number of moles. So if I had 30 grams of Kool-Aid and I could I could convert grams to moles, I'm still going to have that same number of grams of Kool-Aid in the solution. So I'm still going to have the same number of moles of Kool-Aid, even though I'm adding the water to it. So I'm going to visualize this for you with a little image of a model on on the next slides, and then you're going to visualize it. You're going to draw your own model for this and submit it on Schoology. So here is my visual of what I've got going on, my little model that I've drawn for you. So I have pure solvent going in. So I use little red dots to represent my solvent. So here is a close-up of that solvent. So you can see I've got my graduated cylinder here, and I am adding in solvent. Okay, so I have in my beaker here a solution already, and here's a close-up of the solution. You can see the solution has solvent in it, which are the red dots, and solute in it, which are the yellow dots. So you can see that in the image here, my little close-up down here. Okay, so here's what it looks like, okay, closed up. So my result, I want you to notice how in this picture right down here of my solution, after I have added a bunch more red dots, I now have a ratio change. I now have less solute to solvent, okay? So now I have a diluted solution with fewer particles. My volume went up, so notice how the volume in my beaker has gone up. And so now my volume of my concentrated solution, I've got fewer of the solute versus the solvent that's there. So that's a little visual, a little model for you to see what's happening. Pause it here, maybe draw a similar image for yourself, and then I'm going to tell you what your model is that you're going to be drawing and submitting on Schoology. Now, after you watch the next slide that's going to talk about the model that you have to make, you might actually want to come back to this slide and kind of use it as a way to guide yourself for that particular drawing that you're going to be doing on the next slide. So here's your next assignment. You are going to develop a model and post the image on Schoology. If you want to draw the image on Notability, that's fine. If you want to make a video like what I did on the previous slides explaining it, I'll even give extra credit for that. What I would like you to do is I would like you to use red to represent your solute, and I would like you to use green to represent your solvent. And just a reminder for you, the solute is the material that is dissolved, and the solvent is the material that the solute gets dissolved into. So again, think about it as like Kool-Aid. My solute would be my Kool-Aid, and my solvent would be the water, okay? So what you're gonna do is, just like on the previous slide, I showed a beginning and what each of the components looks like, and then I showed the end. You're gonna do something kind of similar. You're gonna sketch a model to show how the number of the solute doesn't change as you add more green solvent being added to it. And then you can comment on your image to explain how the percentage by count of red balls to total balls decreases. Okay, so come back to this. I will post these instructions in the assignment where you'll be submitting it, but you're gonna show what your number of your amount of solute. So you could do like 10 solute and 10 solvent, and then you're going to add in the next image more green to it, and then you're going to make a comment on it as to how the percentage by count of red balls to total balls decreases. Okay, so if you've got any questions, we can talk about this during our class meeting, and you can email me your image if you want to first, and your explanation about how the percentage by count of red balls to the total balls decreases, and hopefully you can kind of draw a model to show this change.